let us come back and solve this numerical. This numerical is basically your NCERT numerical, but very interesting numerical to do. Let us make it simple and learn this numerical. Yes, let's see. Now here, again, freezing point is given to us. So I have to write the formula for freezing point. As I said, first try to write the formula and see what should you find out. So basically, there are two important concepts in this. But here they've given us a 5% solution by mass of cane sugar in water has a freezing point of 271 Kelvin. Okay, that TF is 271 Kelvin itself. Calculate the freezing point of 5% glucose in water. If the freezing point of water is this one, okay, simple. What did they give us? They've given us two conditions. What is that condition? First condition is we have cane sugar. Cane sugar, nothing but your sucrose. Yes, sucrose. Then they've given me glucose also. Done. So they've given like a different this one, isn't it? Weight is given to us. Again, delta T naught F is given to us. TF is given to us. So basically, first let us write the formula. Suppose for cane sugar, if I take delta TF is equal to KF into, for cane sugar I'm trying to take, because KF into M, isn't it? Basically the formula. So KF in molality, here I'm just directly writing the formula. Normally for cane sugar, let me take this as weight by molecular weight. Okay, right, M1 into 1000 divided by weight. Now what is this actually? This is nothing but number of moles divided by weight of the solvent in kg. Simple, isn't it? So nothing, no change. This also let me take as KF1. I'll tell you why did I write that. Next, let us write for glucose delta TF2. Now this is your TF1, this is TF2. This is equal to KF2 into W2 by M2 into 1000 by W. Okay, I've basically written this. Now let's come back and again, because I have, what should I find out? I have to find out your freezing point. I have to find this TF. That's why I'm trying to relate both. Now your KF1 and KF2 both are similar, because KF is only one cryoscopic constant. Now since KF1 is equal to KF2, this is your condition, isn't it? Now what can I then further compare? So what will happen? Your delta TF is equal to, it will be T naught F minus TF. This is one more thing, isn't it? Let's start with the numerical. Now I have first written, then I have taken the condition, then I said this also will be equal, and let us start substituting. When I start substituting, first let us see delta TF. 1, calculate this. What is TF? It is equal to T naught F minus TF. Now for cane sugar, what is given? A 5% solution by mass of cane sugar in water has a freezing point of 271. And water freezing point also is given, cane sugar freezing point also is given. So let's come back and solve this. So let us write. So TF is 273.15 minus 271 Kelvin. Okay, is equal to KF. I have to find out first into, what is W1 cane sugar weight given? 5%. 5% is nothing but 5 grams, isn't it? Yes, 5 grams. Now molecular weight of sucrose is 342 grams into 1000 divided by, what is the weight of water? Weight of water is nothing but, they said 5%. That means 100 grams. Yes, 5 grams dissolved in 100 grams of water. So this is 100 grams. Now let's solve this. When I solve this, I get an answer of 2.15, which is equal to KF1. When I solve this whole thing, I get an answer of 0.146. Just multiplication this. Now KF1 is equal to 2.15 divided by 0.146, which is coming up to 14.7. Okay, done. This part is over. I'm gradually completing the numerical. Now what did I say? I have to find out, what should I find out? I have to find the freezing point of water. I have to find this quantity. Yes, let's come back. Now when I am trying to find this particular thing, delta TF2 I have to find out is equal to KF. Now what is KF? What did I say? KF1 is equal to KF2 I said. So KF1 I already got. So that's the reason I solved that first. KF1, yes, into, what is W2? 5% of glucose, that is 5 grams, divided by molecular weight of glucose, 180 grams into 1000. So they said 5%, so that is nothing but 100 grams. Now when I solve this, delta TF2 is equal to 14.7 into, when I solve this whole thing, I get an answer of 0.278. Yes, 0.278 done. Now I further multiply this. I get TF2. I've not still complete. So this answer I get equal to how much is this? 4.09. Okay, now I still didn't find out the whole thing. So did we do any mistake? No, correct it is. Now 4.09. I have to find out the final thing, isn't it? Now what did we get? 4.09. I very well know TF is equal to TF naught minus TF. So T to delta TF is equal to, what is TF naught which we got? This is for water, that is 273.15 minus your 4.09. so delta TF is equal to, when I subtract it, I get 269.06 Kelvin. So what formula did I apply here? This is TF naught minus TF. This is the formula which I used it here. Simple. So what did I do? I took a numerical, I've written the formula. I tried to compare with common things here. I've written here. After that, I said if these two are equal, then this basically your TF is nothing but the depression freezing point minus the freezing point, isn't it? Now I try to find out here. Now I calculated, I got one answer. Then I took KF1. Then I multiplied, I got one answer. Then KF I took it out and I got 14.7. Now with this condition, KF1 is equal to KF2. The same thing here, instead of KF2, I have written 14.7 and as usual the weight, and when I multiplied I got this is 0.278. Now this is basically TF2, but I want the freezing point of water, freezing point of glucose. So the TF naught minus this one, I got it as 269.06 Kelvin. And this is how we are going to do. Simple numerical, don't get confused, separate everything, try to make a clear presentation in the exam.